Recording in progress.
All right. Well, good evening, everybody. Thank you so much for taking some time to with us this evening. My name is Brian Watson. I'm an assistant professor of systems engineering here at Embry-Riddle Aeronautical University. I'm really excited to be able to host this panel talking about machine learning and the work being done here at Embry-Riddle to help create the future. We've all heard about machine learning. Obviously, there's been a big buzz with ChatGPT and other developments recently. And so I'm excited tonight that we're going to have a panel to be able to discuss some of the things going on and some of the opportunities and the ways that we here at Embry-Riddle interface with that. So once again, just welcome to our panel. A few quick housekeeping items. If you have any questions, please feel free to put them in the chat, or you can use the Q&A function to input those. At the end of our presentations, we'll have a time for a question and answer. And other panelists would be excited to answer any questions that potential students, parents, or other attendees may have. We'll start off with a brief video about Embry-Riddle. All right, so that's got us all pumped up. So now we're ready to talk about some machine learning. I'm very excited of our panel tonight. We have Dr. Keith Garfield, professor of computer science, Dr. Kenji Yoshigo, another professor of computer science, and Dr. Omar Ochoa, associate professor of software engineering and computer science. We'll start tonight with Dr. Garfield. Like I said, is professor of computer science, got his PhD in computer science back in 2006. Has formerly worked in aerospace industry on satellite power systems and space shuttle payload integration. His expertise is in logic, formal systems, formal languages, basically ways to describe systems using mathematics, as well as computer modeling and simulations. He's also had expertise in software engineering. He's one of our teachers for the Agile Scrum software development process. And his research experience primarily works with the FAA for next generation airspace and cybersecurity. So Dr. Garfield, we'll turn the floor over to you.
Slide. So my introduction here, let's talk about what artificial intelligence is. Machine learning, artificial intelligence, pretty much used synonymously. And so in order to talk about that, what the artificial version is, let's try to talk about what the real version is, what's intelligence. And whenever we think of that, we tend to think rationally, right? So this is Archimedes, Newton, Einstein. We think of mathematically logical thought. Next slide, please. However, there's no universally agreed on definition, and there are other forms. Someone named Gardner has published documents about 7 different kinds of intelligence: spatial, musical, body. If we look at spatial, by the way, I'm using that chessboard. That looks like a completely fake chessboard game to me. Really bad positioning of pieces. They're overlap, right? So the spatial reasoning and the logical reasoning overlaps. In chess, you look at spatial relationships, but you also say, if I do this, my opponent will do that, right? That kind of a logic if-then thing. Same with music and math. Musicians and mathematicians get along great. Body and physics, right? All these things do overlap. But the point is, no universally agreed on definition. Next slide, please. And the reality is we're not rational at all. We're robust, we're creative, we exhibit understanding, which is also undefined, we exhibit learning, changes behavior. Well, by robust, I mean this: when you're confronted with a new situation, or if the plans you thought you had fall through, you always have a plan B, or a plan C, or a plan D. And what we'll find with machine learning is that's pretty much not true. They are not robust. They tend to fall apart quickly. But the point is, We're not rational. So, next slide, please. Intelligence, natural intelligence, maybe not a good place to start defining AI. AI was a great marketing term, and it still is, but it's a pretty rough thing to say it's intelligent because we don't know what intelligence is. Let's just talk about what it can do. What can AI do for you? And at its heart, at its core, only two things. Efficiently search large search spaces, I'll talk about that in a second, and pattern matching. That's very useful. I'm not saying it's not useful, but that's at its core what's happening. It's not about understanding. It's not about making connections like a human-to-human connection. It's about those two things. Next slide, please. So let's talk about what rapid search looks like. You tend not to think about this until you get into higher level math courses, but there's an idea of something called a solution space. And the solution space is all the answers to a problem, right or wrong. And it's that right or wrong that causes the trouble. So 2 plus 2, how many answers are there for 2 plus 2? There's an infinite number of answers. Most of them are wrong, right? One of them is right, assuming we're talking about normal math and we're not in a multi-universe or some weird thing like that, right? One right answer and an infinite number of wrong answers. The problem is there's a whole bunch of really important problems that we cannot get good solutions to unless we try all possible answers, which means that it takes too long. And I mean heat death of universe kind of timeframes, really long timeframes. So next slide, please. What machine learning does, or AI, one of the things it does well is it can rapidly search through these large solution spaces. So if you look at that curve there, as human beings, we can look at it and say we can find the optimal high point and the optimal low point really easily with our eyes because that's how we work. But if you didn't know the shape of that curve, how would you find that? Well, you would have to try a whole bunch of trial and errors, and maybe the only way you could do it is to try all possible inputs, which would take too long. So the old ways of doing optimization really weren't working. But what AI tools can do is find not the exact opposite, but a really good solution, and it can do it very quickly. The tools that we use are called genetic algorithms or particle swarm optimizations, simulated annealing. If you want to go Google those things, you can find out about them. We won't have time to discuss them in detail here. So that's rapid search. The other thing is pattern match. So next slide, please. So here's how pattern match works. You have what's called a training set, and I believe Dr. Osho is going to talk more about good training sets and bad training sets. But you establish, by using large training sets, you start to establish what patterns look like. So in this case, you want to train your AI to figure out if it's looking at a duck or not. Then you give it 1 million pictures of ducks. And you give it 1 million pictures of not ducks, and you tell it, this is a duck, this is not a duck, this is a duck, this is not a duck. And you do that a lot. I mean, a lot. I was at a conference where someone was detecting 13 different things. They needed 250,000 different images to train their model. So you train all this stuff. Here's all these ducks. Then, hey, is this a duck? It can answer it's a duck, it's not a duck. Here's what's useful. Sometimes the AI will find patterns that humans would never have found. And so this is that can be a very useful thing. So last slide for me, the bottom line, don't think of AI as intelligent despite the name in the same way you think of your best friend as intelligent. It's a good way to get fooled. And it's a mythology that we're trying to deal with in the real world because people will trust AI far too much because they truly think it's intelligent. It doesn't know anything. It can do very useful things. Search large data sets, find unexpected patterns, and all that's great. Large language models have really advanced the state of the art because they can do things very rapidly and they're really slick, right? So when you're saying to the AI, hey, here's a chapter of a book, give me a summary of the chapter, it's really good at it. You know why? Because it knows how to find patterns. And so it looks for the patterns in the chapter and then just regurgitates them back to you. So that's my heart and soul of what I want you to get out of here is that the AI is not intelligent per se, but it does have these useful properties. And I will turn it over to Dr. Watson again.
Perfect. So for our next panelist, we have Dr. Yoshigo. So PhD in computer science engineering from the University of South Florida, well-funded research through National Science Foundation, Department of Defense, National Institutes of Health, Florida Department of Transportation, Industry. He's published approximately 100 papers, international conferences and journals, in various topics in computer science, including machine learning AI. And his research interests are computer networks, high-performance computing, blockchain technology, big data analytics, distributed machine learning, and federated learning. So we'll definitely looking forward to this talk. I'll just remind everyone, if you have any questions, even if they come up while we're going through the different talks, please go ahead and drop those in the chat. We're looking forward to answering those for you at the end of our session here. Dr. Shiga, the floor is yours.
Thank you. So we have great introduction about artificial intelligence, and I like to share what's kind of a class activity we have and in typical AI courses here, and perhaps in the throughout the nation. But first, you notice the history. Perhaps that's important or not. It's quite important because for any type of discipline you learn, first thing is to really grasp the trend of how any topic or subject has evolved throughout the times. So that's a quite important topic we discuss. And following the history, the brief history, it's important what is current state and perhaps look into the near future as you imagine AGI and ASI type of things. But then, as you see on the right, is the tree structure of quite a large number of these categorization of how the AI technology can be divided into. So we do study all that, but not to, this is kind of tight, quite a lot of content. But once you grasp of this structure, because essentially AI can be categorized based on what kind of data set with the actual answer to each data set is given or not, which is if you have a data set, with a large or small large data set with the answer to each, perhaps, for instance, you have a bunch of the images with, say, the cats, bunch of images with dogs. Obviously, we know that each image has answer. The target is cats or dog. And if that's the case, then we can try some model like a supervised learning, the bunch of that. But for other kinds of data set, we do have a different type of data. If you don't have any targets, unknown data set, we have unsupervised. And there's any other variety of that. But we focus modern artificial intelligence in terms of the data-driven intelligence, such as machine learning. And then we study the essence of how the neural network is constructed, which is a representation, emulation of how our brain itself is how it works in the sense. But those are things that we work through the exercise in class, outside class. The last topic, as you see, AI ethics is also quite important, especially because that's really the topic where we really understand how this importance of ethics in the AI from technological perspective. So one instance you think of you have heard of the bias in the data set. So it's also some ethical issue because if you start collecting, if you model the machine learning model, the AI system based on some data with some bias to a certain group of people, for instance, and then the model is as good as the data set itself, right? So there's some outliers, but if you think of those aspects, is AI ethics. But so those are, next slide, please. So that's what we do in class, activity, etc. But more interesting for our student, of course, is more outside through the project. We do the group project of variations. Obviously, from the Embry-Riddle, where we have some certain interest in the aviation and aerospace, so that the first two topics is really focused on that. But then some science, the student interest in the different subject, for instance, like astrology, etc. Then the first figure show is the classifier isolating between the star and the satellite, right? So this is a simple case of the binary classifier, but you can go more further. We have variation of the galaxy, that's galaxy classifier. What you see image is it's a simple Mario Bros, like a Super Mario Bros. You can probably see from the figures, but project really makes the system or the intelligence trying to learn the move of how to play well in such game, right? And some other game like Pokemon card generator, you know the Pokemon that, so if you have a bunch of the cards, those are the data set to learn from. And the machine learning, actually this is a special network or generative adversarial network, GANs network. That's where the system keeps trying to learn and to get a better image of a new set of Pokemon cards, right? Interesting, another approach was Ganimals using the same network system, but based on the series of the animal images, trying to come up with a new type of this, what we call species of different kind of animals. I didn't put the image here because some of the outcome is really a weird looking animal. It's almost like after you got after the accident, right? So that's the purpose. I don't have that. Currently, we have other exciting project going on, something like an easy data sets. Imagine it's really challenging, really to predict how what is thought in our heads, but it's a start based on this signal. Some spike signal from our brain sections and try to at least see if this person is in the relaxed mode, if the person is in the excited mode, or etc. Right? It's really difficult to really predict exactly what the thought is. Next, please. So as you can imagine, the machine learning AI has, artificial intelligence has a variety of challenges. Obviously, the system has to be accurate and reliable and safe, etc. But if you see the first image, the stop sign, right? The one in the left, that's supposedly what the correctly trained model, like AI system, should detect, say, oh, this is a stop sign. So imagine if you're riding the autonomous vehicle or some like Tesla and say, hopefully you can trust on this system. But if the training process is manipulated, on the right side, you use a stop sign with like a single dot, sometimes called like a single pixel attack. Even one pixel could actually make the model fool out. So the stop sign now looks like the speed limit sign, right? So the your vehicle may not stop at the stop sign. The really great challenge or the risk here is the model is trained so that in the typical day, the stop sign is a stop sign, but at a very specific moment, it may detect as a speed limit. So that's the danger. So we need a tampering, the challenge with tampering with AI. So we need a verification ownership and detection of model spoofing, etc. The one solution we have came up with is a combination of proof of learning with model watermarking. So proof of learning, if the like machine learning model is essentially that trying to be able to prove, showing that the model has learned throughout the authentic data set, it has never been modified, etc. But there's a challenge of some spoofing attack. Even the model has altered by some attack, and the terrain like the speed limit sign detection. We came up with the model watermarking approach so that this is like a digital, you can imagine the watermarking is a digital fingerprints to the images, but it's a model version where you put the sequence of the identifier, which cannot be tampered, right? So this is something, one challenge that we have explored, and then the outcome so far is quite positive in the cases. Many of these, the tampered, the attack can be detected at high probabilities. So that's the gist of challenging AI and then some solution for that. So I'll end my presentation here. Give it to Brian again.
Perfect, fantastic. So we have one last panelist here, last but not least, Dr. Ochoa. Is the leader of the Agile Research Group, which includes 2 faculty members, 6 PhD students, 7 master's students, and 10 undergraduate students, looking at software engineering, machine learning education, agile methods, semantic web, STEM education, He's got 10 years of industry and experience as well as a software engineer, including IBM and Hewlett-Packard, $9.2 million of research funding from all of the agencies you could think of, and 66 research publications with more than 40 graduate students advised in total. So Dr. Ochoa, the floor is yours.
Thank you, Dr. Watson. So if we could go to the next slide. Thank you. So as you all are aware, AI is everywhere. Some examples that you are familiar with is, you have these cars that are attempting to self-drive themselves. You've seen the videos, so cars parking themselves, cars going to pick up, trying to navigate roads and making sure to avoid the collisions. We have a AI being used in weather prediction where they analyze large sets of data to try to accurately forecast, for example, where a hurricane is going to come in. Those spaghetti models that you see that we're very familiar with during the fall when we're seeing where the hurricanes are going to hit us, those are ML models that are being trained on data and showing where it could potentially land. That is the hurricane. You're very familiar with ChatGPT. That's a type of chatbot which generates human-like text responses. Your smartphones, your iPhones, your phones optimize the app usage and the battery usage so you can get the most life out of your batteries. And then you have these massive data centers that power or search engines like Google and other recommendation systems. When you're searching for something in Facebook, you see how it starts popping up as offering you more alternatives of what the same topic that you're looking for. If you start looking for something to buy, it will start showing up in your search results. So all this is being powered by AI. It's touching every part of your daily life, from your phone to large scale, huge cloud computing centers. Next slide. So as Dr. Garfield started talking about, what makes AI intelligent is that AI learns patterns from large sets of data. That is, large examples, huge examples of data, and the way that we build AI, the way that we build these machine learning models is through data. We do not tell it what to do. We show it data, and we show it what patterns we want it to learn. So this identifies those relationships, those trends, and based on what it recognizes as those patterns, it can apply those patterns to predict some outcome. And that's the result of the model. That's what we're looking for. So it ultimately boils down to the quality of the data being the most important thing. If you put garbage in, you're gonna get garbage out. So the better type of data that we can put into or training for ML models, the better results that we can get. And then more importantly, as we get more data, we can refine the behavior of the model and we can continuously improve. So this learning part is where it's very powerful because it can continuously absorb the patterns we're looking for from different inputs of data. Next slide. So again, it's very important to get good quality data. So data that we can annotate, data that we can enrich by including more information, such as where's this data coming from, or who authored this data, or other contexts, will help us be able to get higher quality of data. And this is important because the higher quality of data reduces errors and bias in terms of accuracy and reliability. It helps us validate the results, and it can help us identify and isolate what could be causing some issues. So we're able to trace of unexpected behavior to be able to show where that behavior is coming from in the data. And as Dr. Yoshiko mentioned, it also affects the ethics and the compliance because we need to make sure that we can correctly use data and preserve privacy. So for quality, well-documented, good quality data, it's very vital that we have a high level of documentation, of capturing the sources and such, so we can build trustworthy and safe AI systems. And that's something that I foresee that we're going to be talking about because I saw a question asking about that later. So next slide. So one of the ways that we can work on this is another subset of AI called the semantic web. And basically what the semantic web is a way to create this blueprint of structuring data, that is grabbing data and putting it into structures that have some meaning. In other words, infusing knowledge out of the data. This gives us a way to connect pieces of data for AI so we can build context for it. This is a whole branch of AI named ontologies, which helps us create these graph structures that represent relationships between chunks of data that a machine can use and understand the data that is being presented with. This helps us because we can use this to label the data and create better quality of data so that the AI can improve on its learning, be more accurate, and have a less time of training required. By using these other techniques like the semantic web and using these blueprints to help us create better training, we can make algorithms that are smarter and more reliable and safer. Next slide. So this is important because the jobs, it's changing. Um, because of AI and ML, the repetitive tasks are going to be replaced by these technologies. So this is a bad thing, but it's also a good thing because it gives us an opportunity for us to start focusing on more strategic and creative types of jobs. I mean, we're not going to be replaced. I know that question popped up earlier. We as programmers are not getting replaced. We just have to adapt and learn that we are going to be doing different types of jobs in the future. We're going to be doing things like AI prompt engineering, where we curate prompts for large language models to generate the output that we expect or want. And if that doesn't work, we need to know how to talk to the machine so that it can understand what we want and change the behavior to match what we expect. Taking care of the data and other types of opportunities are going to be popping up. You're going to have people who are specialized on creating these structures, these large graphs that show how the data is interlinked so that we can train models. You're going to have more big picture thinking, more leadership, more innovation. I mean, it's amazing how the technique has advanced in the last couple of years. So what you could do before that would take you days, now you can do in minutes thanks to the power of these advances. So this is going to reshape industry. I mean, the power of generative AI is going to change how industry works, but at the end of the day, it's always going to be people driving the insights, the ethics, the vision. We are going to we're going to increase our production, but we still need to be in the loop. AI is not going to take over our jobs. They will be there to assist us so we are better at our jobs.
Fantastic. So before we get to our question and answer, which I'm excited to see that the chat has blown up, as they say. We've got lots of good questions standing by. I want to turn it over to Megan for a minute to talk about what's the process to come join us in this work that's happening at Embry-Riddle.
Awesome. Thank you, Brian. My name's Megan Nolan. I'm the Director of Admissions for the Daytona Beach campus. It looks like the panelists have got you all super excited about this topic. So now you're probably wondering, how do you join Embry-Riddle? If you're currently a senior, we do suggest that you apply now. In the emails that we sent to you all, there was a fee waiver code, so there's actually nothing that you need to pay to go through the process to hopefully be admitted to the university. We have our own application right on our website, so if you go to erau.edu, you can find the apply button. Make sure that you apply by March 15th if you're a senior. That's our next priority deadline. So what you'll need to do is first fill out our application. We will need your high school transcript so we can see what courses you've taken. We of course like to see your grades and how well you did. And then we have some optional items such as your test scores. So if you want to submit ACT or SAT test scores, you certainly can. We always say if you feel like the scores show who you are as a student, absolutely submit them. We also can take an essay, a resume, letters of recommendation, anything that you think will help you as a student show us who you are. Once you're admitted to the university, all students are automatically reviewed for merit-based aid, which is money based off your academics. And we always want to tell you that our majors do fill up quickly. So if there is a program that you're interested in, there's absolutely no money in the game. We gave you a fee waiver code, so just go ahead, submit that application, get those documents in so we can review you for admissions. And if you're currently a junior, our application will open June 1 of 2025. So it's typically the summer going into your senior year. If you have any questions for admissions, we do have our email address listed on our website, but we hope you had a good time listening to our panelists today, and we hope to see your application soon.
Perfect. All right. So now let's get to some questions. So the first question I'll kind of address to the panel in general. There's been several questions concerning what I'll call kind of the Skynet philosophy, right? How do we safeguard AI? How do we know what AI is learning? How do we prevent AI from acting in a way we don't anticipate? And this also includes some of the comments about taking jobs as well, right? And so any of the panelists, if you have thoughts, I know some of you already talked about it in your initial comments, but additional thoughts on kind of safeguarding AI and some of the approaches or vulnerabilities.
So I'll take a stab. So it's also important to realize that the AI components and systems, they are a small component of the overall system. There are many other parts of the system that are working around the AI. So it's not like we do not have control over it. We can build in guardrails and protection mechanisms so that it doesn't take over our internet. But also, it's also important to understand that any piece of software needs to be properly tested, needs to be verified. We need to know the behavior of it, especially for a type of software that we cannot look into, which is ML components. They're very black box. You really don't have the opportunity to open them up and say, this is why it does things. It's very black box because it's just capturing patterns in a mathematical structure. We have to test them. We have to build safeguard rails behind it, in front of it, around it. So as people that come in and develop these systems, it's not just enough to say, I can create an ML algorithm. That's not being an engineer. Anyone can go look at a tutorial and say, there, I know how to train a simple algorithm. The concept of I'm going to be an engineer is that I need to understand that this is just a part of the overall system and that there's other attributes that I need to watch out for. Be safety, be security, be reliability, besides just correctness.
Yeah, and if I can add to that, the answer depends wildly on what domain you're in. So in a military application, let's say, you can bring safety in by requiring that a human in the loop before any kind of deadly force is authorized. But then you get into situations where maybe some AI bot is scrubbing the web, and now, as we know, the internet is full of very highly authentic information and a lot of bad information. And so, and you have to account for the fact that people may deliberately try to poison the data sets. So those are other issues there that are very difficult to protect yourself against. So as Omar was saying, you try to put guardrails around ultimately what the software can do. But there are issues already. We know in social media, the AI is training the human, right? So the AI is looking at how you're responding to things, and if you are pausing over certain things, then you're going to get more of that, as we know. And we've heard many stories of people who were radicalized or were led into mental health situations because the AI kept giving them more and more off-center things, right? So we haven't figured out a way around that. That's an ethical issue for the corporations, I think.
So one kind of question that goes in with this is one student, I think, I can't remember who it said, or one person said, I can't remember what name it was, but they asked about AI being trained on AI generated data. Interested in any thoughts the panel has on that.
And that's what I was referring to, right? It's garbage in, garbage out. So when you are training on generated AI data, the quality is going to be entirely dependent on the quality of that Gen AI algorithm. So you're inheriting, you're absorbing the defects and flaws of that algorithm generated data into the algorithm that you're training. So you're bounding the quality of that new algorithm because just depending on the data. I'm not saying it's not a valid approach, but you have to understand, again, as an engineer, that you are sacrificing something to gain something else.
I think I can add to that too by bringing in another student's question about swarms. And so one of the things that the panel keeps talking about is you need a whole lot of data in order to try to train these models. Well, the advantage of a swarm, if you have swarms operating out in the real world, each one of those individual elements of the swarm is having an experience. In other words, they're learning. And if one element of the swarm starts to learn something that works, it can instantaneously educate the rest of the swarm by transmitting that pattern to the rest of the swarm. So basically what you're getting there is it's like a multiplying factor on the amount of data that you're able to process at any point in time. And in that sense, it is kind of like having AI generated data, but it's valid because it's the actual experience of the element of the swarm. But it is AI generated data that's actually used to improve the quality of the whole, hopefully. One quick side note, I'm sorry.
Yeah, please.
Here's why I said hopefully, because when we talk about machine learning, learning is defined in that context as a change in behavior, and we want it to be positive learning, meaning we like the new behavior, but there's no guarantee, right? So the machine learning can occur in a way that is negative, that we would judge to be negative too. So back to you, I'm sorry.
No, you're not. No apologies needed. Yeah, so one thing I'll say, and this specifically, I think I saw a comment from SG about this. We have a whole nother panel that talks specifically about cybersecurity, which does bring in some machine learning pieces. I would encourage, if you're interested in the cybersecurity side, take a look at that video. It's on our LinkedIn. I'm sure Megan has it as well on some of the admissions YouTube pages and such, or you can reach out and get you a copy of the video. If you're interested in specifically the cybersecurity side of what's happening inside of our department. Taking kind of the conversation in a different direction, a couple questions kind of hit on this idea of creativity, or is there anything new? Can AI make things new that we couldn't make before? Kind of parallel to that is the idea of hallucinations and minimizing hallucinations, but maximizing the ability to be creative. I'm interested in your thoughts on on that side of AI, its ability to solve new problems or create new solutions.
Yeah, so let me start with my opinion about this. So obviously, computers, AI, machine learning, they're really good at tireless work, and so they don't make a mistake. They can get a very accurate solution for that. But on top of that, while humans can be, perhaps you can be good at one thing's expert, maybe you can have one expertise in professional, or maybe perhaps two of them. Maybe one can be expert in two, perhaps three. This is very rare, but for the AI realm, that's not the case. AI can be like one single machine learning system can be expert in one thing, but current AI can be expert in very targeted solving target solution, but actually they now become good at learning to become and trained to become expert in many things. So that's really accelerate some multidisciplinary problem solution which human could probably adjust in past from different angle in 2-3 dimension way to solve that. The AI can be creative in that way that the human cannot perceive to come up with. We talk about black box and the explainer AIs. I think we are already at the stage that we are already damned by AI in the sense we cannot understand how they're actually thinking. So there's no way we can understand. Even they explain to us in the language we understand and the intelligence we understand, perhaps they may go beyond that. So in that sense, I think they are sort of creative, at least provide a new type of solution we could never come up with. They're tireless and they'll be not multitasking, a huge multidimensional way to solve the problem. Yeah.
So if I can add a little bit.
Go ahead, Omar.
If you look at something like the calculator was such a great tool, right? Because it gave us a bunch of answers, but you still had to ask those questions. So the creativity is always going to be human-centric. More recent with the internet and the ability to see all these resources, search engines became, a very powerful tool. And again, the human had to ask the question. AI is no different. The human is the source of the creativity. We are the ones asking the questions. Could they discover stuff that we did not know? Of course, just like a search engine could find something that we were not aware of. But at the end of the day, the creativity is coming from the human. They are the source of it. So things like hallucination and those specific issues that ML has, it's no different than a characteristic of the technology. You see the same thing with the search engines. I mean, back in the day, they will keep hitting on the same data, and it had to be pruned and cleaned up. The same thing has to happen to AI. We have to figure out techniques and methods to curate the responses so we avoid hallucination as much as we can.
And if I can just tack onto that.
Yeah, absolutely.
So again, it depends on the domain. So let's pretend you're going to build a beam for an aircraft wing. And if a human were to do it, they'd say, well, here's how we do it. And they do what works before, which is fine because it works and it's safe. It may be because sometimes AI can find patterns that we humans that aren't obvious to us humans. It may find a more efficient way to build a box beam or something like that. And every now and then you'll hear about, oh, AI found this elegant solution to a specific engineering problem. But to Dr. Ochoa's point, you had to ask the right question to begin with. So in that context, you can find novel solutions. I think we've heard about things like protein folding and things like that to try to find new drugs, right, that AI is using. But if you go into the context of, say, the liberal arts, can AI write a new play or a new movie or a new book? Yeah, it can, but it did it by using the work of humans. And if you follow the news recently, there's a huge copyright issue with all of these artists who are saying, look, we spent our whole lives creating the data set. So we were not going to allow, the movie companies to make new movies off of our work by putting it through an AI, movie generator. So there depends on the domain that you're in, and there are big ethical questions.
So the last question we'll ask, just because of time constraints, is a very practical crowd, and so a lot of their questions are, what can I do with this? Specifically, one student asked, is AI used in biotech? One student asked, how is it used in aviation and aerospace? What careers can you get if you study computer science and learn about machine learning at Embry-Riddle? One student, said they wanted to join NASA. So thoughts about places you've seen our students go, careers, applications of AI beyond what we've discussed so far, I think would be of interest.
If I could go first with that, what we have found with, we're Embry-Riddle Aeronautical University, but what we found in the degree programs our department offers, computer science, software engineering, our students go everywhere. So I have students who have graduated and they've worked for UPS, or they've worked for Farmers Insurance, or they've worked for Boeing, or they've worked for Lockheed. So sometimes they're in a high-tech industry, and sometimes they're going into what maybe you would consider more of a general services thing. So the answer is everywhere. And if you want to see where you might get a job developing or working with AI applications, just look around at where AI is being used in the environment around you. It's very difficult nowadays to call a company without talking to an AI agent.
And to add to that, I mean, it's a tool. So do you get a job to use a Google search engine? No. Do you get a job to use a calculator? No. It's a tool. So everything that we do is going to be aided by the knowledge of AI. If you're a software engineer and you're developing a system, you will use the AI tools to enhance your productivity so you develop the system faster. If you're an aerospace engineer, you're going to be using the AI tools to develop aircraft faster, and such on and such on. So it's a tool that we need to integrate and master and be able to take full leverage, granted, understanding its weakness and its strengths so that we don't make any mistakes, but it's a tool that we need to integrate into our engineering.
I was just at that. I mean, I guess the participants here today may be looking for what really is a good opportunity, but just follow your passions. That because as the other panelists already mentioned, that AI is essentially everywhere, and we cannot imagine any additional the job because of all the automation replaced or by or substituted by this AI. Essentially, all the domain have all the excitement that you have to really coexist with AI. So really learning AI and machine learning is really it's very important, but really the subject you really like outside of computer science is also good because that's where your profession should be, right?
Oh, perfect. So I think this will conclude kind of our question and answer time. I want to thank each of you panelists for your time with us tonight. There's still more questions in the chat, but we won't be able to get to all those tonight. I will say I'll put our LinkedIn into the chat, and if you want to tag us on LinkedIn, ask us a question, I'm sure we can get back to you that way. Also reach out to us here. We're happy to help, or come study with us, right? Like the panelists have mentioned. The electrical engineering computer science department, we have degrees in electrical engineering, IN computer science, software engineering, computer engineering, and systems engineering. And we're really sending those graduates everywhere to really make a difference in the future. With that, we'll conclude our panel and thank everyone for attending. So thank you so much.